So I mentioned earlier how one of the things we're going to do in this conference is a lot of dialogue, and the mechanism by which we're going to do that is through panels. Each panel is going to consist of 4 experts who are leaders in their field, but importantly, they've also shown real leadership in the industry as well overall. And I'm going to ask them a couple of initial questions so they give some viewpoints and scope out the debates. Then they're going to be further questioned and even challenged sometimes so that we can figure out the key issues and try to make them more relevant to our business. I'm going to begin each panel with questions of my own, but I'm also going to ask the audience for questions. What you need to do is go to your phone, go to the normal browser that you use. Doesn't matter if it's Android or Apple. You don't need to install an app. Simply go to that web link over there, type in your question. You get to choose whether it's anonymous or not, and it should magically appear on an iPad that I've got on my chair. I'll try and get through as many of those as I can. The first topic we're going to talk about is diamond manufacturing. Diamond manufacturing, as many of you know, is the process by which you turn a rough diamond into a polished diamond. It's a process that's seen a series of small improvements over the last 15 years, which together have been transformative. So you can now make a bigger polished diamond out of the same rough diamond. So there's a yield improvement. You can make a better polished diamond. Sometimes it's higher clarity, sometimes higher color. You can cut a diamond so that it sparkles more as well. 20 years ago, GIA Triple Excellent was an aspiration. Today, it's a standard. The question is, how much further can things go? And where could automation fit in? What I want to do actually is pause for a moment and take an example from another industry, from Adidas, who makes sports shoes. In 2015, they moved their shoe production from low-cost labor centers like China and Indonesia, and they moved them to Germany in a fully automated factory. They used robotics and computerized knitting to create shoes with very limited human intervention. That factory was so successful, they opened another one in Atlanta, in the US, last year. This not only changed Adidas' supply chain, it also changed their consumer proposition, because people could now buy a made-in-Germany product. But Adidas went further. They are experimenting with 3D printing. So you can go into a pop-up store, an Adidas pop-up store, figure out what sort of shoe you want, and have it 3D printed for you there and then. So you can literally walk out or run out, for the more athletically minded amongst you, run out with custom-made running shoes the same day. They've also taken a stance on the environment, on recycled and reclaimed plastic. This year alone, they're going to sell 11 million pairs of shoes that contain ocean reclaimed plastic, which is amazing. So the question is, how much of this can be applied to the diamond manufacturing process? If we took it to its logical extreme, could we get to a position where you could put a rough diamond in at one part of the process, and you came up with a polished diamond at the other, with limited human intervention? We've already seen a couple of companies start to pursue the same. What are the implications of a dramatically less labor-intensive process? What does it mean for people who are manufacturing today? What does it mean for the miners? What does it mean for the consumers? Then there's the related issue of diamond grading, which has been very important historically in building credibility in the product, and has also historically been very labor-driven as well. How will diamond grading evolve as the diamond manufacturing process becomes more automated? And could diamond grading itself become automated? I don't think that these issues have ever been explored in a forum like this. I think it's an industry first. I'm excited to be exploring this with you. And to discuss these topics further, I'd like to invite Bernard Rickershagen, founder and CEO of Sinova, David Block, CEO of Sarine, Tom Moses, who heads up research and lab development at the Gemological Institute of America, the GIA. And finally, Farid Salih, who heads up technology and innovation at De Beers. Welcome. Good morning and welcome. So the theme today is going to be diamond manufacturing in this panel. And one of the things we talked about is how this part of the supply chain has seen a series of small improvements over time. David, I'd like to begin with you because your company has been one of those that's been at the forefront of some of these changes. Can you talk about how far do you think diamond manufacturing automation could realistically go?
So I think actually what you showed with Adidas is inevitable in the end. How long it will take to get there, what the implications will be within the industry, or questions maybe there aren't answers to today. But that is inevitable. I think in the end, diamond manufacturing has come a long way from 20 years ago when it was basically entirely manually processed. People used to pick up the diamond, take a look at it. You had experts. Back then there were people called cleavers who used to decide based on their experience how to plan the diamond and then cut it. Processing was entirely manual on polishing wheels. And that's come a very, very long way over the last 20 years. But I believe that today we're at the beginning of another evolution in diamond manufacturing that will bring it all the way to somewhere in the vicinity of what you showed of how Adidas manufactures. And I don't think that's just to replace manual processing with automation. The introduction of technology and the automation of such processes bring a lot of additional added values to the industry. So I think that is the key part of this next evolution in diamond manufacturing, rather than just seeing how to automate it and replace manual processes. I can give you an example on diamond planning. The reason diamond planning became today's standard of how to manufacture diamonds was because that it added a lot of value to the rough diamond. So a rough diamond that used to be worth $1,000 20 years ago, today is probably worth $1,500 or more, because a lot of added value was created during that process. So it didn't just replace people, it actually added a lot of value to the process.
I think there's a whole discussion to be had about how technology and people interact with each other. That's a very important discussion, which I'm going to come back to later. But a very important point that you've made is the idea that the scope of automation in diamond manufacturing could be far and wide, and could be actually directionally or potentially even the same as what we saw with Adidas. Bernard, I want to come to you because you're one of those, you're heading up at Sonova, one of those companies that has been making strides in diamond manufacturing automation. Can you talk about what is practically possible today?
Yeah, thank you very much. With pleasure. So we have started probably around 7 years to develop solutions for the diamond industry. In fact, Sonova is coming from a different industry. We are from rather the, let's say, classic or conventional machining, 5-axis machining of metal for aerospace, medical industry, diamond tools. And in fact, it was just a question of time that we start to think about natural diamond for the gem industry. And with the development of laser technology, we found the right laser source, and we started, with one customer, a very famous customer in Europe, Belgium, to saw diamonds. Just one step of the whole process. We modified the machines, we developed the software for this. And we have seen, and of course our customers, that there is a value of this technology because we can reduce very much the weight loss. Now with this parallel laser beam that we have invented and patented. And then the next step was, this is now working nicely. We have sold a number of machines. Then we went into pie cutting or blocking, bluting. And so I think we went further into, let's say, into the manufacturing pipeline of diamonds. And then finally, I think everyone can imagine there must be something coming behind that. We should not stop there, because this technology is able to do a lot more than we thought maybe in the beginning. And we had the machines, and we have the experience from the other industry, how to shape a diamond. Now I bring the the next term, shaping diamonds, is in discussion since a while, and this is something we have developed over the last years. And what I can announce now is, yes, we are ready to propose this solution of fully automatic, it's important, automatic cutting and shaping of diamonds. And yeah, we are ready now. And
congratulations. I mean, that sounds like a pretty exciting announcement. Do you want to say a few more words on that, or shall I try to circle back to that later?
Maybe, yes, later.
Okay. I mean, I think what I just want to explore with the two of you, on this, is what's the scope? You know, we talk about automation potentially in diamond manufacturing. David and Bernard, what's the range of diamonds that could potentially be automated? Are we looking at the full spectrum, or are we looking at a particular segment of diamonds that could be automated?
So I think with any technology, the technology starts where there's the highest added value, which is generally the bigger and more expensive diamonds. If we look at, let's say, two of our technologies that we've introduced over the last 20 years, diamond planning and the Galaxy, which scans the internal part of the diamond, they all started at the bigger, better sizes. So in the beginning, planning was done on 2 carat plus rough. Today, we have 1 point rough diamonds being planned on technology. And that happens over time as the technology develops, the cost effectiveness of the technology improves, and I believe the same will happen with technology for manufacturing. We say today diamonds are polished, but when you think about it, diamonds are not really polished much today. Most of the processes are already done with laser systems. So there's very little polishing in diamond polishing today. And I think that it's just a matter of time that the size and the quality of the diamonds get lower and cheaper. It will start with the big sizes, and it will go down gradually as it becomes more cost effective.
If we look ahead, what do you think, Bernard and David, are the hardest parts of full automation in terms of cracking it? What are the biggest barriers to doing that?
I think in our case, it's the fact that a diamond is a very individual workpiece. You know, we know from other industries, when we drill holes in turbine blades, each of the turbine blades is the same, and it's easy to automate this. No? But with a diamond, it's much more complex. They are, the size is totally different, inclusions, and so on. So for the laser, each time the laser sees something different. So the big issue, the big problem for us, how we can control automatically the process. So when we generate one facet of the diamond, the brilliant, then when do we know when it's finished and we can move to the next one? Because we have to be absolutely sure, 100%, that each facet is completed. And we should not spend also more time. Then time is, of course, important in our case.
Thank you. I mean, that's a very comprehensive overview of diamond manufacturing and where it could go. Farid, I've got to ask you a cheeky question here. Why did De Beers take a stake in Sonova? And how does that fit into your overall strategy of technology and innovation?
I don't know if you've ever been mountain biking in Switzerland, Anish, but no.
Do I look like the mountain biking type?
In all seriousness, from a De Beers perspective, we looked at our business model.
Okay.
And we said there are two things that we need to be doing as an organization. One of them is optimize our existing assets. The second one is innovation. What does innovation give us? Innovation protects us against disruption. Innovation allows us to better propose a value proposition to our customers. In looking at innovation, we came across various different opportunities. You would have seen De Beers in the last 5 years have launched GemFair, Lightbox, tracer, but we also recognized we needed to focus on specific technologies that could catalyze the diamond industry. The first of those was with respect to distribution and handling. How do we use robotics? How do we use automated storage and retrieval systems? How do we use digital ecosystems to move our diamond product between systems and within systems? The second one was this complexity of automated cutting and shaping. To condense our pipeline, we once brought in some people who looked at what we were doing, and they said, your ambition should be to mine your product and get it to the customer in a mounted diamond jewelry ring in 1 day. And we asked ourselves, what was the biggest bottleneck that stood between us and the customer? And the one clear place was around speeding up the process around automated cutting and shaping. And then we then looked at what opportunities there were to do that, and there are several, of which we are aware. But clearly Sonova and the laser microjet technology, in our view, stood the best chance of being adapted and adopted by the industry in terms of a long-term solution.
No, thanks a lot, Farid, and that raises several questions and is a very detailed answer. Bernard, want to ask you to comment as well, because you work in a number of different industries, and you've partnered up with De Beers as an equity shareholder. What was your feeling about working with De Beers, and what was your rationale for partnering with them?
Yeah, so it's about now, I think, 4 years ago that we found together. But I think at that time we had 3 business units at Sonova. We had industry, which is metal machining and different end markets. We had the semiconductor, and we had diamond. And of course, everyone knows De Beers, and we were convinced that De Beers would help us contribute to our development of the company, especially, of course, naturally in the diamond industry, with all their knowledge of the diamond market, of the end customers, but also of the rough stones. And I can say today, yes, this was a good decision. And we had now 4 years together, and I think very exciting, and discussions and so on different levels.
Thank you, Bernard.
And I should like to maybe add to what Farid said. I mean, I was at 2 weeks ago in a factory in India with guests from China, and we were doing a tour of one of the factories. And during that process, the host explained that there are, I think if I'm not mistaken, 106 different stages of manufacturing, which is a little bit crazy. And the consolidation of that manufacturing process is, as I said in the beginning, not to replace manual people. The 1 to 2 years of stock that currently exists in the pipeline creates a lot of difficulties for our industry. We're not manufacturing to consumer demand. And if we can shorten that cycle dramatically, we can adapt what we are manufacturing, the rough that comes out of the ground, to what the consumer wants in a much more effective way. And I think that is the key value addition of such a process.
Thanks a lot. I want to talk about, like I said, the labor and tech interdependency in a few minutes. Tom, welcome. GIA is a consumer brand of sorts. It's become a real consumer trust mark. GIA is the world's largest diamond grading lab, I believe. How do you, when you listen to all of this so far from a GIA perspective, how do you think diamond grading would evolve in light of automated diamond manufacturing?
Thank you, Anish, and it's nice to be here this morning. So clearly, similar to diamond manufacturing, diamond grading, and certainly at GIA, we've been working on developing more automation. Interestingly enough, as many of you know, GIA was the creator of the 4 Cs, and it was the early 1940s. And our first color machine, which helped establish that kind of the yardstick D to Z, we developed in 1945. So we go back that far as using instrumentation to support diamond grading. But kind of fast forwarding in recent years, and some of you are probably aware of our partnership with the Watson Group at IBM, and we, of course, today much of the diamond grading in the lab is done instrumentally. But what we began a project about a decade ago, a little longer, with trying to automate clarity, and made slow progress, but not great progress, and decided a couple of years ago to partner with IBM, and are making great progress with, of course, machine learning, and they're certainly world leaders in artificial intelligence. So, and I think similar to what David said, it isn't necessarily to replace our existing graders. It's speed, efficiency, but I think more importantly, it will allow us to reach more stones or handle more stones. And at a time where consumer confidence perhaps is waning, we look at this as, so for example, the numbers I've often heard about on average of the number of polished stones that typically are produced in a year is about 1 billion stones, and most of that, 90%, is below a tenth of a carat. But we see great opportunity to using this automation to handle more stones, handle them faster, and at a price and efficiency that supports consumer confidence.
Thank you very much, Tom. David, your company has a Sarine technology lab. Can you talk through that technology? Because as I understand it, that is actually a technology-driven grading approach.
Yeah. Well, I mean, we're a technology company. We're not gemologists, even though we have gemologists supporting our development. But then we're a technology company, and we put a goal a number of years ago to see how to resolve the issue that Tom described. How do you utilize technology to automatically grade diamonds? That can increase the repeatability and the accuracy of grading. That increases consumer confidence. And it enables to reach efficiently and cost-effectively a very much wider segment of polished diamonds. So we've been working on that problem for a number of years now. Last year we opened up our first grading labs, which is basically just a tool to utilize that technology. And it's all based on artificial intelligence, machine learning. And one of the reasons we did that is because today there are many different standards of grading, with GA standard being the most predominant. And because we didn't want to create our own standard, the only way to really create a technology grading system that's automated was through machine learning. So our technologies basically learn how to grade in a similar way that, I have a 2.5-year-old son. And so he's, a year ago he learned colors. So you show this is blue and that's blue and that's blue. And to someone who doesn't know what blue is, that's all looks very different. But over time he learns that. So that's a very simple way of describing what we've done with our machine learning. And the objective is to create a fully automated process for all the different aspects of diamond grading through technology.
Just one question that springs to my mind, and I don't know how many of you in the audience are in the same boat. Can one of you take a crack at explaining what artificial intelligence actually is? Because sometimes I think I've got artificial intelligence. Like I think I'm intelligent, but I'm not really. I don't know if that's the definition.
I could start to try, but then I'll probably end up being as confused as everybody else. Anish, I think you asked that question, but you make a great point. So let me get to the point, and then I'll try to answer the question. Is that there is a confluence of a significant amount of technologies that most of us simply don't understand.
Yes.
And we feel in some way left behind. I'm always reminded of trying to program I'll show you my age, the VCR.
Yes.
And at some point I gave up. And with all of these technologies as leaders, if we don't at least have a working understanding of them today, we are going to be in trouble. So technology, unfortunately, is no longer for the technologists, is my one point. And artificial intelligence and machine learning could be, for all intents and purposes, a foreign language that we are faced with as executives. So my understanding of artificial intelligence is it's replicating using computers, computing algorithms, signal and image processing mechanisms, the decision pathways that human beings employ to make decisions. It is not perfect, but it has improved significantly in the last 10 years in terms of enabling a broad swathe of all of the machines that we talk about. So I'll start there, and maybe my colleagues would
sounds
want to add.
great. Tom, can I just quickly ask you to comment on that, because you were the first one on the panel to talk about artificial intelligence. So do you want to, first of all, add to what Fareed has said? And second of all, can you just quickly talk through how you're using artificial intelligence practically at the GIA today?
Yeah, I mean, I think that was a good summary. So how GIA is using it? We're using it in a few ways. I talked about we're now starting to phase it in, integrate it into clarity grading. But we are also using it in treatment detection. So, for example, we would collect certain data, and over time, what we realized, especially as we've expanded, there's a small number of experts, but don't have the opportunity to see this wide range of stones. So essentially, what we've tried to do is do the data collection, but to simplify it, is use their knowledge and decision making, and through software and algorithms to help make those decisions. So for treatment detection. So those are two examples, and we continue to look for other opportunities. Another area that outside of Diamond, but I'll mention it, is, as you know, we also test and identify country of origin for rubies and sapphires. And we go to mine sites, collect samples, of course, characterize those with large data sets. And then when an unknown sample comes in, we're also using different types of statistics and artificial intelligence to help us determine the origin of colored gemstones.
It's very interesting. This is really about diamond manufacturing, but Fareed, I just want to give you a quick chance to just talk about artificial intelligence in any mining work that you've done. Is artificial intelligence that's something that De Beers is familiar with further up the supply chain? Just in a minute or two.
So again, I think what De Beers is very invested in is in what today is being called the fourth industrial revolution. So for those of you who was waiting for that term to be put into the room, there it is. But what does that simply mean? There's a confluence of technologies, of which artificial intelligence is one, that is enabling De Beers to leapfrog into new spaces. Let me name some of the others. Robotics is one of them. The Internet of Things, how the Internet talks between machines, is another. 3D printing is a fourth. It's the confluence of those things which De Beers is using. So, for example, in our Venetia Underground project, 10, 12 years ago in Finch, we deployed autonomous driverless trucks, which meant the trucks drove themselves between the crusher and the ore passes. Today, we're looking at autonomous loading, hauling, and drilling. That means no human intervention, and the machines and the infrastructure and ecosystem around it are making the decisions, be that around how fast the truck should go, how fast we should drill. What underpins all of these things? One of them is efficiency, but quite honestly, more importantly for De Beers, it's around safety. We believe that when we use artificial intelligence, when we use machine learning, when we link it with robotics, and when we link it with internet, we can take the people away from the diamond face, so to speak, and so bring a safer product to the consumer of tomorrow and tell a better story. So that is an example.
And that's very interesting. I mean, you've got an efficiency gain, and an economist's definition of efficiency can be that you get a product from the top of a supply chain to the bottom of it to the consumer as cheaply and as quickly as possible. That is one standard definition. I'm not saying that's the one we always use as an industry. So there's an efficiency, there's a social safety angle. Can I just ask you, Fareed, how did that affect jobs and labor as you automated some of these processes? For instance, you no longer need drivers to drive those trucks. What happened to those staff?
So thankfully we engage in all of our labor sending areas with both the communities and the governments in those areas. And we made sure that we found alternative value-adding activities for those people to be redeployed.
Okay.
I would acknowledge that that's not always possible.
Okay.
And there is inevitably going to be times where you either have to retrain people or alternatively let them go. It is fair to say that both there's a commercial rationale, but also the governments and our partners that we engage with just recognize that to be competitive, there is this tension. From a De Beers perspective, we don't have all the answers in this regard. And with our partners, we are looking at ways, whether it be taking people out of the diamond industry and putting them into adjacent industries, a la beneficiation, or alternatively totally redirecting them to alternative job sending activity within the countries in which we operate. I think this is still a task for us to grapple with collectively as technologists and as leaders over the next 5 to 10 years.
There's a very interesting example from the mining perspective. David, from the diamond manufacturing perspective, do you see more applications for artificial intelligence?
Yeah, well, actually today, most of what we do, we're always looking at how that can add value. And I can give another couple of examples of directions that can be used. But maybe I'll go back and try give you a very simple answer to what machine learning is, which is a part of artificial intelligence. You could teach someone what is blue by saying it's RGB from A to B. Okay, so give them an RGB. Probably most people have no idea, including me, what RGB blue is. And you could say this is blue and that's blue and that's blue, and that's how most people learn blue. So when you take that problem to a computer, you could teach the range of RGB, or you could provide it many different examples of what is blue, and it will learn. So when you provide it a new shade of blue that it's never seen before, it will still recognize it. So that's a little bit of the very simplifying concept of machine learning. We're doing that in many different fields, not only in the field of automated grading. One of the fields that we're doing quite a lot of research is in tension. Diamonds have a lot of stress, and that creates a lot of challenges with diamond manufacturing, damages along the process. And that's very much impacted by how you plan and how you manufacture the diamond. So once we're able to measure and create data sets of stress, we can now start understanding the impact of that on how the diamond will react when being cut or polished in a certain way, and then starting to try and evaluate if we do something in a certain way, how that could impact the diamond. Today that's done in a very manual process of a person looking at the diamond and trying to guesstimate as best as he can what will be the impact of a certain cutting or polishing of the diamond. So utilizing data that's created on our technologies, we are researching how to create a benefit and reduce damages and loss during the cutting process and polishing process. So that's just one more example.
Thank you very much. And Bernard, I just want you to quickly comment on this, and then I want to kind of move on to one or two audience questions that we've had so far. So thanks for sending them in. Bernard, just quickly, do you have any more comments on artificial intelligence, either in diamond manufacturing or in other industries that you've experienced?
Yeah, so artificial intelligence is a word that a lot of people now talk about and believe this is the future and we have to go there. Now, applied this to the diamond industry, I think we have some steps to do before. If I see how diamonds are still manufactured today in a very manual way, control of the quality is still by men, and I think we have to go from industry almost 2.0, we have to make a big jump to industry 4.0 today. And it's really the time now to do this. I think we all understand that today's situation is very particular. And we have now Industry 4.0 means automation and automatic control of the machine. So the machines become somehow intelligent. They have sensors in the machine. That's exactly what we have done in our a new machine that we have called the Vinci, the fully automatic cutting and shaping system. And so it's today a machine that runs autonomously, and it has intelligence inside, as I said. We call it the breakthrough sensor that detects the moment we have finished one facet, it moves then automatically to the next. So we can just load the stone into the machine, and then load the program, of course, into the machine. And then the machine is doing the whole shaping of the diamond itself without any intervention. That is Industry 4.0, and we believe with our technology we can make a big jump. And the title here of this conference is Disruption in Diamonds, and I think we are all convinced that this has the potential of disruption in the way how diamonds today are manufactured.
A very important part of today's discussion, by the way, just for those who are not technically minded, is going to be, we're going to be talking about what are the implications. So in many of the panels, what we're going to try to do today as a template is try to understand the details and then try and figure out what it means so you can draw practical conclusions from it. We will come to that. Please be patient. I know this is a very technical, very involved discussion. I've had a couple of questions about blockchain and traceability, and so I want to just quickly change tack and invite someone to just explain to me and the audience, what does blockchain mean and what does traceability mean? Tom, do you want to have a crack at this, actually?
Well, maybe I'll talk about the traceability. I'm not sure I'm the greatest expert with blockchain. But certainly traceability, it sounds just like it is. It's being able to trace the raw material through its supply chain to the finished product. And clearly we are seeing more and more of an interest in that, especially in the big brands. But as far as the blockchain, I certainly, Fareed, you and Tracer and blockchain perhaps would want to talk about that.
Sure. So just from a De Beers perspective, we think of blockchain as an enabler, and I'll talk about blockchain in a second. But when we think about the customer, we think that we need to give the customer three things. One of them is traceability. The other one is authenticity of the product that we're selling them. And the third thing is provenance. If you are able to link in whatever way you choose to do that, using blockchain or anything else, we believe we'll have a better story to tell the customer into the future. Blockchain, as I say, is one of the legs which enables traceability. And in essence, what it is an immutable ledger that sits within software that enables you to track a series of transactions and ensures that you can't change the underpinning transaction if you want to go back in time and for whatever reason cook the books.
Do you just think, just to ask the straightforward question on this, do you think that that is practically possible with diamonds specifically, and actually physical products specifically? I can understand, for instance, why that works with Bitcoin, for instance, which is kind of not a physical product. But could it practically work with diamonds at the end of the day? David, do you want to have a quick crack at that?
Yeah, well, I think the big challenge is how do you connect the physical with the digital? That's where it all boils down to. So blockchain is a container for information, but the question is how do you connect between the physical diamond, the information about that physical diamond, and ensure the correct information about that specific diamond enters the blockchain? And I think that's the industry's biggest challenge today with traceability, because I think three of us, both Tom and Fareed and myself, which all three companies are involved in traceability programs, agree to the necessity and the value addition of traceability. And I think the main discussion is how do you ensure that the end consumer, who you want to create that confidence, where that diamond came from, that it was properly tracked and is authentic, as Fareed mentioned, how do you ensure that the information that is provided to the consumer is verifiable information and is authentic? Having that information just in blockchain is not enough. You need to ensure that how the information enters the blockchain and where that information is from and how it was verified is taken properly care of, and that's the biggest challenge today with traceability.
I think, sorry, Tom.
Yeah,
please
and
go.
I'd just like to add to that, I think David has pointed out, is, I'll call it the weak link. And so we're encountering more and more experiences where someone cut a diamond of a different quality or in fairly, we're seeing it more frequently, a synthetic diamond to match a GIA natural report. So something that we actually have 3 different methods that we're working on now and hope to deploy sometime in 2020. A simple method and a tool where someone who has the diamond would take an image or some other type of measurement. It would go to the GIA cloud, reference to a particular report number, and we'll come back and identify that it's that diamond matches that report. And I think that's kind of addresses that big concern that kind of the weakness of the blockchain. But that is clearly an important part, and we're working a lot on that right now.
Just quickly, on a scale of 1 to 10, how confident are you that you can solve that so-called weak link, that you can link that product, the physical product, with a blockchain immutable ledger to 100% accuracy? On a scale of 1 to 10, how confident are you could pull that off, Tom?
We are very confident. On a scale of 1 to 10, right now these are in different stages. One of them is in a pilot stage. I would say at this point 9.
Okay.
Yeah.
Does anyone have a higher or lower number on this?
Okay, I think the factor that also should be considered is time, because as with any technologies we mentioned earlier, technology improves over time. I think the benefits of being able to do a lot more than is done today with regards to traceability, which is mainly based on declarations, audits, warrants, that's today's system. At the moment you add technology, that already brings it to another level. Exponentially higher assurance that that diamond has been tracked. Will it ever get to 100%? Is it possible? Probably yes, but I think it will take time and will be a process that level of assurance will rise and get stronger and stronger. But I think a lot of the different solutions out there are well on their way to getting there.
Farid, I just want to quickly check, one of the reasons we've talked about traceability and blockchain and matters like this is that, it all sounds great, okay? It seems like an important factor. It's great that you know where this stone has come from. But how confident are you, through your own research at De Beers, that consumers actually care about this?
Anish, I think you kindly answered the question earlier because you mentioned the evolving nature of the consumer. And all of our research points us to an ever more mature consumer when it comes to those 3 critical issues of traceability, provenance, and authenticity. The millennial generation increasingly cares. Greta Thunberg, if you heard her speak the other day, cares around these issues. And I think if we are not answering the plea in the diamond industry, then I think we're going to fall on hard times. So it needs to be one arrow in our quiver of answers we bring to the industry, be it around our approach to environmental issues, be it around safety, be it around how we can give assurance about where our products are coming from. I think it's a have to have, not a nice to have in our industry.
Bernard, very quickly, you've done a bit of work with the Swiss watch industry as well. And obviously Swiss watches is a fantastic example of how they used origin as a means of marketing and differentiation and even prestige, consumer value. What's your opinion on traceability as a little bit of a semi-outsider in this debate? And why do you think it truly is important to the diamond buying consumer?
Yeah, I think watch industry is a good, case where we can take some lessons from, because the watch industry went through a lot of changes during the last maybe 20, 30 years. It started with the quartz watch and the Japanese competition. And before, the Swiss watch was, the number 1 in the world. And the Swiss watch industry had to think about, okay, what can we do? now. How can we keep, the economy, the employment, and so on here in Switzerland, a very expensive country, and Japan was very competitive, especially with this new quartz device and automation, precision, and so on. And then the Swatch group came out of with this idea of a very cheap product, a plastic watch, and they found a way to produce plastic parts in high precision. This was really new at that time. Nobody could do this. They looked, by the way, they went to I know the story from the founder of Swatch Group. They went to Lego and looked how they make very precise bricks in plastic, and they took this technology and applied it for the watch. This is a bit the story of the reason for the plastic watch. And they produced in this country, in Switzerland, and became very successful. Today, as everyone knows, Swatch Group is the largest watchmaking group in the world, and I think we can learn from this. Because there will be changes in the coming years, drastic changes. And I'm personally convinced that the diamond industry will not be in the next 5 years as it has been during the last 150 years. So a lot of reasons for this. And I think we have to go the technology way. We have to adapt new technologies. We have to become more efficient, faster. We have to react faster than today. To market demands, because they are also changing.
Sure.
And
just Bernard, I think you're getting onto a very important point. So I think, at this point in the debate, we need to start talking about some of the implications of these developments. We've talked a lot about artificial intelligence, we've talked a lot about blockchain, we've talked a lot about traceability. And we're also starting to get some kind of questions in as well. And I think the key thing that people want to revisit, which has been said earlier in the debate, is the impact on the labor force, right? I think this has become a topic that's coming through loud and clear. Tom, I'm just going to start with you before we move on to diamond manufacturing, which in some ways is a bigger topic, but it's just one small part of a holistic whole. Do you think you'll get to a point where actually diamond grading does not need human graders?
I do not think that we will reach the point where diamond grading will be done totally without some human interaction. There's 2 points I would make. I mentioned earlier, what we are looking at with this technology is shorten the pipeline, greater efficiency, and being able to address or grade stones and sizes or qualities that we're unable to do today. So really, I'll call it using this as a growth method, and also ultimately to create more consumer confidence. There's one other kind of comment that I would like to make. It's somewhat adjacent to, and David reminded me of it as he was talking about, kind of what is blue. And, we've talked about a lot of, these technical kind of clinical things. I just want to introduce and mention that one of the aspects we continue to look at is, kind of the study of hedonics, so of pleasure. So using David's description of blue, he's right. So to teach a machine to do it, you use a colorimeter and map out some standard color space, and so if something falls within that measurement, then different parts of that could, with a word description that makes sense. So part of, and we use this method a lot when we were developing the cut grading system, which you described. So we modeled, it was about 10 million different sets of proportions, and they gave us some indication of which stones perform better. But at the same time, we made sure to, I'll call it, calibrate that system or that final determination with human involvement, looking at gemstones. Because ultimately, we are the important part is beauty and this side of it. And I just wanted to introduce it and not lose that as we're focused so much on the technology.
I think one of the key questions though around grading is that, and something that David said, is the issue of consistency and consistent standards over a long period of time. Does a GIA FVS2 today, is that the same as a GIA FVS2 20 years ago? Maybe it would be, maybe it wouldn't be, but there's an element of doubt. If you were to bring in artificial intelligence or machine learning, could it be beneficial to actually effectively have an automated process? It's just a debate. I mean, I don't have a view either way. David, I just want you to quickly comment on that before, Tom, you just...
Yeah. Well, I mean, I guess we have different opinions, but I think grading in the end can be fully automated. It's a matter of time, because grading needs to be consistent and deterministic, and therefore any evaluation of a diamond that is done by a person, eventually, if with enough data and enough advanced technology, could be done by a person. That does not mean that there is no room for very irregular aspects of diamond grading. There are always, I agree on that aspect, that there are very irregular parts of diamond grading that may remain manual. But on the bulk and on the whole, yes, just like 20 years ago, people didn't believe that you could plan a diamond through technology, and that's what happens today on basically every single diamond. It's because the technology evolved. So it does take time. It is an evolution and not an instant revolution. But I do think that is, just like we talked about manufacturing, it's inevitable that manufacturing will shift eventually to full automation, and I believe the same will happen with diamond grading.
I think an important question that's coming through is the idea of automated manufacturing and what it means for the existing labor force. I think, David, I just want you to kind of build on this a bit more. So if you ended up seeing much more automation in diamond manufacturing and it became a fully automated process like the Adidas example, what does that mean for existing manufacturing centers like Surat, for example?
So I think it's very difficult from today's position to look forward 2, 3, 5, 10 years ahead and understand the implications. So I think we need to look a little bit on history. If in the 1800s people would have said, the Industrial Revolution is going to take away jobs, we'd be stuck back in the Stone Age. So maybe I can take an example from our industry and our experience. When we started introducing technology for diamond planning, everyone told us, okay, you're going to take away all the jobs of the people who are doing that today manually, years of experience, the cleavers and so onwards. And if we look fast forward 20 years to today, we have about 50,000 people involved in diamond planning. It's a lot more people, probably 10 times or more than were involved in back 20 years ago in that process. It's added a lot of value. So sometimes jobs evolve and professions evolve to something different. Sometimes, as Farid said, they do disappear. But in the big picture, when you look at how technology has added value to different areas in the diamond industry, as well as other industries, on average, it doesn't remove jobs.
I guess
it changes them. It evolves.
Exactly. And I think the question would be then that if you don't need the same types of jobs, right? So maybe if diamond manufacturing becomes automated and a lot of processes happen through robotics or machine learning or a combination of all of those issues, and you effectively have job displacement, so you have jobs moving from one area to another. In the future, in a fully automated world, David, what do you think would be the attributes of a successful diamond manufacturing center at that point?
I think I talked about it in the beginning. I think the benefits of that automated manufacturing will bring to a much shorter supply chain and resolve a lot of the issues the industry today is facing with unneeded stocks that get stuck in the pipeline. Why? Because the rough comes out of the mine today and in the best case scenario, on average, reaches in a year's time to the consumer and sometimes a lot longer. And that gap creates a lot of difficulty to adjust the supply to demand. If you can now manufacture a diamond in a day, as maybe the dream would be, you could do like cars are manufactured today. It's actually a little bit crazy to think about that you can manufacture a car, I don't know, in a day or 2 or 3, I don't know how long it takes, to order based on the demand in the consumer market and adjust your supply side. And we haven't yet reached that stage, or not even close yet of reaching that stage with diamonds, and you have such a long pipeline. And I think that's the biggest advantage. It will solve financing issues that were talked about earlier. We have 2 years of financing in the pipeline. If you had a very efficient supply chain, you could resolve a lot of those issues.
Just
Anish, can I just add? I think we're going to be competing in a different way. In a way, what we do today is not what we're going to be doing tomorrow. Sorry, that sounds very trite, but we're not going to be selling the same product. We are going to be bespoking our offer to our customers in very different ways, whether that be around cut, whether that be around integration with nanomaterials, whether that be evolving. It will open up possibility to reframe our product. And I think if we're simply thinking about how are we going to be replacing our existing manufacturing capability, the lens is possibly a bit skewed. It's about saying, what opportunities does it open up for manufacturers today? And having said that, I think manufacturers will have to disintermediate beyond manufacturing into all of the things we spoke about earlier, be that up to retail, to understand how they can better meet the needs. So just maybe a reframe to re-challenge our assumption that it's going to be about producing 3 billion stones in this particular size category, in this particular shape.
I think that's a very important point. And I think that what you could do is you could end up with a more efficient supply chain, a supply chain that better meets the needs of the consumers, more dynamically meets them, and there's a more responsible and more attractive product because at the end of it, it's traceable and there's much more integrity around it. The fact remains, though, that if we were to have an Adidas type situation where you see manufacturing moving away from low-cost labor centers, holistically, that's really improved Adidas's model. But individual businesses, individual people who might have been the contract manufacturers for Adidas in China and Indonesia, they've had to, it's a fancy word, pivot or change their business model or potentially exit their model. And we have quite a big Surat manufacturing, labor-driven manufacturing process. So, I guess the question that's at the heart of this, and actually it is coming in a few times, is, are we looking at a scenario where actually the same could happen, that diamond manufacturing doesn't need to happen in India, that it could either happen in Southern Africa, potentially as part of a beneficiation drive, or indeed in Western markets? Bernard, can I bring you in? When you've looked at other industries, for example, watches, how did that play out? We've talked about Adidas, but I just want to see if there are other examples as well. How did that play out, that increased automation in terms of labor redeployment?
Okay, maybe in Switzerland the situation was a bit different because they had an industry there and the risk was to lose it, and they have taken decisions and applied technologies to keep the industry there. But it was already in a high price country. No? I think in our case here, the opportunity for India is that there is today the whole industry. It's more than 90%. Over time. So I think that the basic situation is good today to make changes, but I think I would recommend doing these changes rather quickly and not waiting. I think it's the word should be acting and not just waiting and leading the changes. Even the technology changes, not waiting that new locations will open of manufacturing, maybe in Africa or in the United States. Taking the leadership there and accelerating and being in the front of the technology change.
Anish, I think there's a bit of a misconception. The Indian diamond industry is not just manufacturing. It's a very significant part of the supply chain. So manufacturing, yes, in numbers of people employed within the industry, that's a significant number. But I think the Indian diamond industry is way more than just a manufacturing center. It's a very significant part of today's diamond supply chain. And therefore, even that if manufacturing would convert to much more automated, which I believe it will, that doesn't mean that the Indian diamond industry is going to disappear tomorrow.
I think that, again, just kind of following up on a couple of audience questions, there is a bit of, I don't know if concern's the right word, or discussion around some of these topics, that if India's competitive advantage today is low labor costs and skilled labor, right? It's an area where India's built, but especially Surat has built considerable expertise. If you have a fully automated diamond manufacturing world, right, it doesn't mean that it would move from India, but it means that the core purpose of manufacturing being in India today shifts. So you do theoretically have the possibility of that shifting. And we have to be realistic because, this conference is about, helping businesses prosper. I don't think, I think that we have to be realistic about what the implications of this could be. So, for instance, if you're a driver of a truck and that truck has now become an autonomous driving truck, then that driver's job, that human driver's job, no longer exists, and maybe that person can be retrained. So my question to you, in practical and honest terms, because we've got a couple of Surat manufacturers here, if you were giving advice now to a Surat manufacturer, what would you advise them? David, can I start with you on
Yeah.
this?
Understand that in the end, the change is inevitable. I believe that it doesn't matter if it will be Sonova or Sarine or other companies who introduce technologies that create that change. In the end, it is inevitable. The world and all other industries are going there, some faster, some slower. I think you need to understand where the industry is going and start already before the change happens in a widespread manner and dramatically to prepare yourself. Again, if I go back to an example, diamond planners were afraid in the beginning that they would lose their jobs. So we took those diamond planners, we opened up a school in Surat, and we started training these people how to utilize the technology and actually empower them to actually increase their skill level, rather than saying, okay, this is going to replace me. How do I use this tool? How do I use this technology in order to better myself? And as I said today, there are way more in terms of numbers of people that are involved in the planning process today as compared to 10 and 20 years ago. They are much higher skilled. They're using advanced technologies. Their working conditions are way improved. I mean, it's like a high-tech city if you go into a diamond factory. So I think you need to see how to utilize the existing skills of the people involved and how to adapt them to technology. And that you need to do earlier on in the process and understand it's going to go there and how do you adapt yourself.
Tom, we haven't spoken about grading here, and I know you and David had slightly different opinions on the degree of potential automation, and actually only time will tell. I guess if diamond grading gets more and more automated, do you actually see diamond grading just being an integrated part of diamond manufacturing? So it could be an on-site machine, it could be part of another process. And then, sorry, a two-part question, which I know is annoying for you, is that, and then if that's the case, do you actually need grading labs at all?
I think it's a fair question and one we've thought about, and I do anticipate a scenario, at least for some percentage of diamonds, perhaps where we would provide technology for a factory that would collect the images in a prescribed way that GIA is monitoring and calibrating. That data would go to a GIA cloud, and a grade would be applied. So what you've described, that is a scenario that we're looking at. And it could work for a substantial part of stones. And again, what's been mentioned a number of times here is another process to shorten the manufacturing delivery time.
I think one aspect, and I think is one of those questions that has to be asked, is that if diamond manufacturing, let's take a world where diamond manufacturing just becomes automated. Let's say diamond grading becomes automated. Let's say we have Tracer and other traceability and blockchain initiatives. Do you feel, Farid, that miners could just start selling polished, right? So it's just an extra part of the process. You mine the diamonds, you bring them out of the ground, and then what you do is you just manufacture them in an automated fashion, and then you sell polished onto the market. You've got the ready-made traceability there as well. You've got a complete package and dramatically reduce time to market.
I think our customers provide significant services over and above selling polished. So from a mining perspective, it's not simply a question of automating the cutting and polishing process and disintermediating our customers. Having said that, as those other components of the ecosystem too become automated, we talk about financial systems, HR systems, and all of those things becoming automated, it is a possibility. In my mind, not a short-term or medium-term possibility. We are now talking 10, 15 years hence, when it makes sense for the industry to consider that strategic optionality.
Can I quickly just check with Bernard and David here? We talked about automation, and there's a spectrum here. Let's say you get to 100% automation or whatever, and we're at, I don't know where we're at today. But in how many years' time, Bernard, I'd like to ask you the question first, as you've come with a new machine and special announcement today. How long a time frame do you think it would take to get to something approaching full automation for all intents and purposes, a dramatically less labor-intensive manufacturing process? If you were to put a number on it.
Yeah, it's always difficult to predict the future. No? If I say now a number, then later on people will ask me, oh, you have told 1 year and it's now 2 years and it's still not there. But I think there is let's say, a pressure in the market. There is a strong demand for this solution. And it's not necessary, I think, that we have to do a lot of marketing now. I think it's a natural next step for us and then also for our customers. And we have today a solution that means it goes from the rough stone, it is planned, and then mounted in a special holder, and then we get the planning, the information from the planning tool into our machine, and then we shape the whole diamond, and we have a finishing step, still a small polishing at the end, and that's it, more or less, I would say. Then it's a grading, of course, but we can, I think, reduce very strongly the whole pipeline, and we do not depend anymore on particular skills, and on so many man work. So this is certainly going to change. And from the time, I think we are ready to propose the solution, and how now the solution will be, how quickly the solution will be adapted and implemented. That's of course another question. It's also a question, of course, at the end of capital. Of course, automation means also always need of capital. These machines have to be financed, but we, let's say, we consider various models at the moment, how we can come over this obstacle of capital, which is today more and more difficult, as everyone knows.
I think, yeah, I mean, I think a constraining factor on getting to automation quickly will be amount of investment and capital required. I just, in terms of kind of speeding, as we're kind of starting to get closer to lunch, and people have shown a lot of stamina to sit through this. I want to just make a couple of remarks on this, and just kind of, because obviously this is a public forum, there's media here, and I think the questions that have come to my mind is, or some tentative conclusions are, there is a high chance that there will be diamond manufacturing automation. There is a high chance that there will be significant amounts of diamond grading automation. Traceability is inevitable and important part. That's not which will become a must-have. These are three tentative conclusions. The implications of those conclusions are that the existing skills that are used in our industry are potentially not the relevant skills that we're going to need in 10 years' time. So where you have labor-intensive processes in Surat today, you might not need the same workforce in the future. And I think we've got to look at that as a possibility. Whether it's inevitable or not is another question. It was inevitable for Adidas. They didn't need that people. There was a dramatically less labor-intensive process. There simply was that. And so what we're looking at here is a situation where the skills might be different. If De Beers does, I mean, if let's say it is a strategic possibility that De Beers sells polished instead of rough, like in a way, why wouldn't you if it's an automated process and it happens quickly? You reduce your capital, your cash conversion cycle, you can get product to market quicker, you can interface closer to the consumer, which is beneficial. You may sell to different people. You know, you may not sell to a rough trader, you may not sell to a big Surat manufacturer. So I think in the audience, the key question would be to really monitor this carefully, because depending on where you sit in the business, these types of changes are potentially very disruptive for you as a business. There's a positive element to this, that from a consumer perspective, it could be very, very positive indeed. But you've got to find your own place as an individual industry stakeholder in that new world. I think that what I'd like to do in the last 10 minutes is, before I circle back to you, Bernard, as I promised about your new innovation, I just want to quickly ask you, straight after lunch, we're going to be talking about lab-grown diamonds. I thought it'd be very interesting just to get your views on lab-grown diamonds. And in particular, how do you see diamond manufacturing automation and lab-grown diamonds, manufacturing automation and lab-grown diamonds interacting? David, can I start with you on this?
Yeah, sure. So I'm not even getting to the discussion about lab-grown and are they real or not. But I think if we focus on the manufacturing side, the processes of manufacturing lab-grown are fairly similar to natural diamonds. And therefore, I think if it is cost-effective, and I think that's a big question, because if the lab-grown diamonds do not retain value and the cost of the raw material drops dramatically, I think there is a question of how feasible it will be to use technology on the manufacturing of lab-grown diamonds. On the flip side of that, if you want to efficiently manufacture lab-grown diamonds, you have to use technology. So I think there's a bit of a challenge there of how to find the balance between it being feasible to use it on one hand, on the other hand, feasible to manufacture it without it. And I think that's a question that a lot of the technology providers today are asking themselves, including us. We have quite a bit of our technologies being used in the lab-grown diamond segment for different purposes. But over time, depending on what happens with the pricing of lab-grown and where that goes, that's a question how to make it cost-effective over time.
We've got a whole panel on lab-grown coming up, but does anyone else want to comment on lab-grown in this panel? Bernard, you look like you want to say.
So lab-grown diamond, I think it's another part of the same topic of automation, because now you can produce the diamond in a machine instead of in a mine, and it's very, I think, an exciting time, and nobody knows how the market will really react, how the consumer will behave. What we can just say, there's a new generation that certainly thinks differently than our generation still about environment, climate, and so on. I think we have arguments on both sides. There are arguments for their product or their rough product, and nobody knows today, okay, how will be the market share between both? How will the market go this way or the other way? Of course, the good thing for us is we participate on both markets, so we look forward to see these changes in the market, the systems today, the technology to produce these diamonds become affordable and accessible for a lot of maybe also new players. You have to think about this as well.
I think from a technology company point of view, that's very interesting, and we'll be debating that. I just want to say I have been having a couple of questions come through the iPad, but I just want to invite the audience. I've only got time for one or two questions. We do have a number of manufacturers in the audience. I understand there are a couple of microphones around. Does anyone want to just quickly make a comment and take a view, or either comment or ask a question to any of the panelists? Stefan Fischler. There is a mic catching up with you very fast.
Just a question I sent to your iPad, Anish. What will be the effect, you think, the panel think, on the leverage of the midstream, which it's almost lost today? I mean, in terms of if the midstream can start an embracing technology, which I believe it should, do you think there will be a serious impact in terms of the distribution of leverage along the pipeline, and I would say a more balanced leverage, which is not the case today? Thank you.
So thanks, Stefan. So this is a question about, if I understand correctly, bank financing. Today, there is quite a lot of cutting and polishing debt in the supply chain. How could that evolve with increased automation? Farid, do you want to have a crack at that one?
I reflected our reason from a vision point of view at looking at this is shortening the pipeline. In so doing, reducing inventory. In so doing, giving banks more confidence around what is there, how long it's going to be there, and how long before it moves through the system. So I think it can only improve the bankability of the diamond industry if we increase its efficiency.
I'll add to that maybe that as you utilize more technology within the midstream in the manufacturing process, you have more transparency. You have more capability of the bank to understand really what's going on with its funding. And the more transparency the bank has, the more ability to look into what it's funding and where it's going, I think the more confidence the banks will have. So traceability is based on technology within the pipeline, no matter what kind of technology is used. And I think that will definitely also benefit the banks and give them a lot more confidence.
So a shorter supply chain and a more reliable supply chain. So you probably will need... one last question. Does anyone else have a question or a comment they'd like to make? No, I guess you're all hungry. Sorry.
Hi. Just commenting on David's point that the apprehension by planners before the technology will take away their jobs actually in turn resulted in much positive transformation. I think our industry needs at each segment try to look at the positive ways the technology will transform us and help understand at each pipeline what are the ways we have to embrace any way it is coming. But exactly like you mentioned, what are those ways if automated manufacturing is coming, automated certification is coming, how we can leverage that and make a positive change. And I think that's what the theme of the event, that's a comment.
Thank you very much. That is exactly the theme of this, so that we can understand these disruptions and try to see how they can bring positive change to individual businesses.
Yeah, I'm reminded with your comment of it and listening to this that, and I think Fareed used the term earlier, it's kind of bespoke. And when one thinks of, I think much of the retail bridal business today, people they're selecting a mounting and then putting a diamond in. But what we're talking about now is they could actually design their diamond in addition to the mounting. I think that's a real possibility, and I think that creates again, enhances this experience with our product. So I think that's a real possibility.
In the interest of time, I'm going to close it for questions. The panelists are around over lunch, and so there will be more opportunities to ask questions one-on-one. Bernard, you mentioned earlier the idea of you bringing to market, in fact, if I understood you correctly, an automated faceting machine of sorts. Do you want to say a little bit more just before we close for lunch?
Yeah, this would be perfect. By the way, I have a few pictures. If you allow me, I could show, then I think it's much clearer for everyone.
I don't see why not. It's been great looking at your faces, though, from this angle. So, sure, is there...
I have a memory stick. Yes. Thank you.
Fantastic, thank you.
Okay, thank you.
We'll just give him a minute or that. We've got
It's very short, so just a few pictures. Okay, so we call the machine Da Vinci, Diamond Factory. Da Vinci because he has also disruptive inventions and solutions at his time. And Diamond Factory, we will explain why we call this machine virtually a diamond factory. We can state that it's the first automated laser full faceting system for round brilliance. So we can process the 57 facets in a single process. That's just an example here. And the outcome you see on the right side, it looks still black. It's a little carbon layer, and it has to be removed, and also a remaining microscopic roughness. So there is a finishing step at the end. So the Da Vinci Diamond Factory consists of the following elements. We have our field-proven 5-axis CNC laser cutting system. This is the base of the whole solution. We have a breakthrough sensor. I explained it before, so that detects the moment we have broken through a facet, so that we can move on to the next one. We have the software that transforms the data from the planning tool into NC data for our CNC machine, and then also a mounting station that allows to mount the stone after the planning precisely on a specific patented holder that then is mounted into the machine. So finally, what we do with the Da Vinci system is the following here in the whole pipeline from the rough stone to the polished stone. So after the planning, we have a first step of sewing, the table sewing. Then the stone is then mounted on this table on a special holder. And then we mount this, the stone into the machine. The data are transferred from the planning tool into our shaping system. And then we do automatically all the 57 facets in a certain order. Then at the end, as you have seen before, there is still then a need of a final finishing step to remove this carbon layer and to come to a very smooth surface. So there's, with this solution, no need anymore for blocking, for bruting, and control of the different manufacturing steps. So we have to plan it from the beginning, of course, right, because the machine is just executing a program, and then you get the polished stone in a very precise geometrical shape. So what is the performance of the machine in regard to cutting time? You see here typical process times we have experienced over our tests in the few last months. And you see also the range of stones that have been machined. So roughly, you can say 1 carat stone is shaped in about 1 hour. And then in function of the size, of course, it takes a bit less or more time. So what are the key advantages for the diamond manufacturer to adapt this technology? First, a sharply reduced production time, as you could see before, and pipeline, translating to a much lower inventory and related interest costs. Then a higher and more predictable polished yield, because now it's a machine that is executing the cutting program with a very high accuracy of about 3 microns. Of course, no manual polisher could do this. We get an increased value extracted from the rough stone. We can even recover the cut-off chips from the stone, versus today, of course, polishing dust. Then we have an increased manufacturing flexibility, as you can imagine. You have seen the size of the machine. So, principally, you could install such a machine, including planning and final polishing, into a container, into a garage, and you can produce polished brilliance. We have a strongly reduced footprint, just mentioned. So, virtually, therefore, the name Diamond Factory, virtually entire Diamond Factory in one system. So, that's just the conclusion. Now we make possible the just-in-time manufacturing. Today, you produce diamonds that you have not yet sold. In the future, tomorrow, thanks to the Da Vinci Diamond Factory, you will produce diamonds you have already sold. So, thank you very much.
Thank you very much. Can we take this opportunity to give a big round of applause for all 4 panelists, please? Thank you very much.